Hello, my name is Darian Caro, and this is my Ubisoft 2019 Programmer Next submission. So as you can see, I have a Pac-Man and a little red box, which acts as my AI. The little bounding box that you see around the player is the collision box. It has some little wonky physics, but it does collide properly like a box on certain flat planes. The enemy is pathfinding, broken at the moment, but it is pathfinding nonetheless. So for this game, I decided to go with a scene graph structure. So if we head over to the game test where I utilized the entry point for my scene graph, we have my world here, which it passes in a size, and my world is a game world class, which inherits from a game element, which is a interface, which uses update, render, and onEvent, three core functions that necessary game elements will use. So we go back into game world. It's quite a simple class. It also handles our events and also initializes our scene. So we pass in a world size, we hand that off to the scene. Our world will then, from game test, listen for events as well as generate the map differently. It'll also utilize this call here and update everything down the chain as well as render it. So if you head over into the scene class, I initialize a new tile map and I randomize it, as well as scenes also hold a map of game objects as well as names. That way I could keep it all nice and organized. I chose to do this because it helped me pick and choose what to render, so as opposed to having a bunch of game objects floating around and having to call render and draw on each of them, I can simply add them to a map and allow the map to handle it for me. So it's very efficient and future-proof. Pardon me. So if we go into the scene, the way you initialize it is you pass in a name and you can hand it off. Player is an inherited member, so you can also typecast you can typecast a parent to a child, and you set the position, pass in a random position, as well as I created a transform class, which all game objects utilize. I got the idea from developing in Unity, which just simply holds a vector2 int position, seeing as it is a tile map, and a vector2 rotation and scale. As well as I created an AI class. So the things that get passed down to the game objects are a scene, a name, and a potential overridden transform. So if we head into the game object class, pardon me, it also inherits from iGameElement. iGameElement. So we have initializing functions, a couple overridden ones, and because it is a game element, it allows us to use update, render, and onEvent. And I did this so that we wouldn't have to depend on the scene and the world. They would just share logic, seeing as they are game elements. I can then set the attached scene and get it. This is because I needed to have access to my tile map for my game objects, and this was the best way I could think of it. So they currently all hold a transform and a name that allows them to share that, as well as a protected, so any children members will have that as well. So if you go into the player class, which is where the main game logic for the player happens, we have an update function where I check for input, which merely just uses the application and checks for a button, and then uses events that I've created. In this particular instance, it is an input event, which I then queue it up in the world, which is another reason why I needed access to the scene, because I needed access to the world. So you pass off the events to the world will then, before updating the scene, process the events, which just calls on event on the scene. And in this specific instance, in the players on event, they will get the event, and if the event type happens to be an input event, we will typecast it as an input event and get the data from it. Also, game objects utilize collider objects, as demonstrated before. Collider objects are very simple. They just use a position and a direction, and a movement direction to calculate the front of the object, and then calculate an offset to create a box. Once you store the offsets, we check for collisions with the tile map by getting, if it's the floor, so this is a big series of if statements that check each point, whether or not they're touching, to get the face or the collision normal. Pardon me. If there's no collision, just set the collision normal to none. And then we also, if there is a collision in the player, we ask it to resolve it by passing in our movement direction. That way it can be clamped. So for example, collision left, we'll clamp it so that it can only move to the right. And then we use delta time and our direction and move the player. We created a draw circle function to allow for a Pac-Man shape, which just merely uses a position, a radius, or the amount of points in a radius, as well as a color vector 3. Now the AI class also inherits from game object. So you initialize it, we get the tile map, and we hand it off to the Pathfinder. The destination gets set, or the final destination, pardon me, gets set by converting our tile space to world space, world space to tile space. And then we set the next destination, which essentially just looks through our Pathfinder, finds a path, gets a char array, or pardon me, an int array, and passes it off. And from that, it'll get the indexes, which will pass in positions to the AI. Now it's quite a simple pathfinding class. It uses a path node array and open indexes as well as a size. So it'll find a path by using the current G cost, adding it to open, and use a while loop to search through and calculate the Manhattan value, which is our F cost. Sorry, our H cost, and our F cost will be our final value. So once it does all the calculations by doing, this is an A-star pathfinding algorithm, it'll check neighboring nodes to find out the most beneficial route. It was just poorly implemented by myself. And that is it. I hope you take my submission into consideration. This was a great experience, and I'd like to thank you.